Okay, so I think today is mainly want to hold office hours and then questions and develop next steps for finalizing this kind of guest side API stuff. Uh, but outside of that topic, were there any other opens that people had questions about?
I don't have any. Hi.
Okay. Um, so I think going back and forth with Jason on that patch set, I think the biggest outcome or the biggest change that's going to come out of that is just simplifying the trust levels even more. Just have those trust levels be disabled, adversary, and full trust, and pull pull the trusted kind of DMA attribute out to be a separate flag. And so a bus driver could like if a bus knows that this device is supposed to be within the or within the TCP, it can set that bit during enumeration, and then we'll just treat that device as inside the T when the driver binds. And then the trust levels are really going to just be about whether we are going to use an enforcing IOMMU policy or not. And so we're kind of, I had the idea that you actually elevate trust to enable DMA, but I think we don't. I think we can. I think it's cleaner if we separate it. So I agree with Jason on that point.
So what does it mean to say T plus an advisory? Does that mean does that mean the configuration is expecting a stage 1 IOMMU, like VIOMMU?
Yeah, and I think we're not going to babysit the administrator. So if they said adversary, then um, then if there's a VIOMU, if there's a stage 1, then that stage 1 will be put into the enforcing mode of no batched invalidations and kind of strict DMA and no and bouncing partial page boundaries, all those kind of safety things. And I think I was looking at least the ARM specification. Like we can't detect that a given device is going to be connected to a given SMMU.
Yes.
But we can detect this that there's one present. And I think that's probably going to have to be enough, because I can't think of a way that we can actually tell the user ahead of time. I mean, so we can either I mean, yeah, we can either babysit and say, yeah, if it's adversary, then and we don't find a IOMMU, then we could at the late stage we can say we can give up.
Okay.
Or we can say you have you saw this SMU. It's and that one should also indicate that it's inside the T. Like what are the why would somebody go through the trouble of adding one and not using it for all the devices? I mean, is that a valid configuration? Would somebody bind multiple? Would somebody bind multiple devices, and only some of them are covered by the virtual RMU, by the stage 1? Is that a use case that we need to support, or we just say like, yeah, it has to be all of them, or
Yeah, I mean, there was this interesting proposal of how a device would transition from untrusted to trusted, right? So the notion was if it was an untrusted, it will not only be DMA direct, and the moment you flip that to trusted, I mean, with it will kind of you start using the stage one, right? Kind of like because the idea was that untrusted will not be using the stage one at all because it's kind of really hard to kind of do the all setup uh, for that stage one untrusted and then because it's a different SMME. There are two different like even though there's in physicality there's one SMME, right? I mean in reality there is like two sides of it. One is the realm world side and the normal world side, and then the moment device move from it, it essentially would look like a new IUMMU gets attached to the device, and it's kind of like really hard with the current support we have upstream, right? I mean, a device IUMMU always remain attached to that device. Did that make sense?
yeah, that makes sense. Um,
Yeah,
I mean,
but I think we can get to that. Like, I mean, at this point, we are not even having a VIOMMU kind of integration in the CCA path. So. So we can get to that. I was just trying to understand the semantics there, right? How does this even so advisory means whatever is PCI untrusted or device untrusted code path currently we have, that would be what advisory would kind of enforce, right? Even
yeah,
if
yeah,
we have
it would be to deploy all the same safety mechanisms, but just
yeah,
deploy them on private memory.
you went on mute.
Oh, sorry. Yeah, it was deploy all the same mechanisms, but deploy them on um, private memory instead of shared memory.
Yeah, got that.
But I mean, but I don't want to design us into a corner that can't easily accommodate a virtual stage one. Um, would it be the case that the IMU is stage one's always there, but like the detection would be that it can't do anything besides pass through until it's switched to secure mode?
Yeah, that was the discussion. That was the earlier discussion we had around this. I think even on the list, Jason was suggesting that's the easiest to kind of manage.
Yeah. So as long as this trust framework proposal doesn't block that, then I think
Yeah, yeah,
you, you were saying something about how the device actually changes ID, or that was to get around that was to get around the IOMU is always present, so we have to re-enumerate a new device, and then we can have the IOMU present from the beginning of time.
yeah. So the way so how will we so the question was like now that we want the untrusted device not to have an IMME attached and the trusted device to have an IMME attached. One of the proposal was like the conversion from non-secure to secure would appear it as like the device unplug and the device getting come back again under a different virtual bus topology with which had like an IMMU available. So I don't think we have code for any of this, but these were like different ideas, which I think Suzuki also talked about it in one of the plumbers sometime back to kind of discuss about how this would actually appear in a. The challenge is how do we kind of like um, make this all work, right? I mean, there was this another conflicting requirement where if the device is not capable of 64 DMA, operating in untrusted implies it needs to have a VIOMMU. Then how do I transfer that that device to trusted mode. I don't think we fully solved those details yet.
No, a trusted device that needs bounce buffering to be
Correct.
shared. Yeah.
The trusted device may not need bounce buffering because we know the address, the MAC address doesn't really require bounce buffering. But if it is an untrusted device, because we use the top address bit as an alias for the share, like a private shared memory, the DMA address that we generate would be really large, and the device DMA mask doesn't allow to kind of use such a large DMA address. So the way we said we will handle this is like, there would be a VIOMMU which the device can use. So in an untrusted mode, the device requires a VIOMMU for operation because the top bit set DMA DDR is large and the device can't handle that. Now, how do I convert such a device to trusted mode? It's actually the opposite of what I said before, where untrusted mode will have a VIMMU, and then the trust mode we don't know yet. I think that needs more discussion
Oh yeah.
is to figure out.
Okay. So the other thing that was in that patch set, I don't did I reply to you, Alexi, or not about the fact that we're not multiplying the interface report offset by 4K anymore. So there was a discussion. I think a the result of which is going to be clarification published and to try to get out ahead of implementations that made that assumption. Like I think there's agreement that yes, it could be read that way. And then I think PCI SIG is settling on telling everybody to get on board with the it is a full 64-bit address definition. So if that's news to you, talk to your PCI SIG person, but that's what I've heard is coming.
So they changing PCI spec?
They're clarifying PCI spec, yeah.
To make start address in TDI report a physical address, not 4K.
Not a 4K PFN.
Okay, great. Why?
Why? Because why? All I know is that it read that way. It was defensible. My recommendation was, if anybody thinks this is not the right interpretation, take it to the PCI SIG, and they did. And then PCI SIG, I think, is coming down and saying that was the original intent. So that's all I know.
Base and size in units of 4K pages, says 7.0 spec. Like, how can you misinterpret this? Really?
Yep. Right. Like, so I don't know if they're going to put a comma and say base address and size in 4K. I don't know. So I'm waiting for that to be published, but I don't want to keep the Linux implementation going on something that's not going to be the standard. So,
So this is the MMIO reporting offsets, and then trying to find out the start guest real address, right? Because some of the bars can appear, like some of the bars can be shared. Isn't it like, so at least this is related to that clarification of the CCS spec also, right? Right. And if I get this correct.
well, no, that's something different. This was about what units is that offset reported in? Is it reported in bytes or page numbers, number of pages?
And they are saying
Linux
it's bytes because we also thought it is 4K.
Okay.
And the clarification is to say it is in bytes, is it?
My understanding is the clarification is going to say it's in bytes, but
okay. I can also double check. Yeah.
So they'll double check and basically I think that yeah, if people are already shipping the other one, we need to You can tell PCI SIG, yeah, it's too late. It's too late. My assumption is they must have thought that it was. Well, I don't know. I wasn't there, so I'm not divulging anything confidential about what the discussion was. But my assumption is maybe something along the lines of there's no implementations yet that are shipping, so it's okay to fix this now.
Okay.
But
I think Samsung may be the one, like, I think they had TDISP,
shipping.
not shipping, I guess. Probably they had an NVMe TDISP setup, I guess. I don't know anybody from Samsung is on the call.
Yeah, yeah. Check what your device is doing, and talk to your PCI SIG person.
Okay.
And
I mean, if Epic CPU is now being sold, right, Turing generation, and that thing supports VFIO, and it does parse the report, does it count?
I think I would say it counts, right? I mean, but the report is it parses the report. Yeah.
This is the ASP parsing the interface report, is it, Alexei?
Yes.
Oh, that is implementation.
That's annotation, yeah. So maybe this is why I haven't seen. Maybe this is why I haven't seen it published. Maybe the like yeah. So basically, talk to your PCI SIG people. Like I want Linux to just like there's specifications and then there's practical reality, and there's no point in Linux sitting on a nice clean spec when it doesn't work with reality that's shipping. So that's my recommendation: is talk and see if that's going to be a problem.
We fixed it once in the last few months. We can fix it again. It's just
You can fix it again.
No.
At some point, suppose somebody want to ship the code and then we can't fix it. Like once it's upstream, then really can't fix it. But yeah, I think people are saying, "Oh, it's not upstream yet, so we can still change it." Like, well, no, not really.
Well, the report part is not upstream, so yes.
Yep. Right. But the other thing that you were talking about, Anish, and Alexei, it was good for you to confirm, is that the interface report, we're all going to stick with the definition that the reporting offset is always going to be bar aligned. So you can always just mask off the size of the bar. The offset will always be at least aligned to that bar size, maybe bigger, like because the virtual bar might be smaller than the physical bar, but the thing will be basically physically bar aligned, and you don't have to worry about unreported parts of the bar. So that part's okay.
This part I like. Good.
Okay.
Yeah, your patch series had an option to choose between two different possibilities. So that
I had a patch at the end with a question mark that said, here's the way that if you have to deal with holes and you don't do the alignment thing.
Okay.
The intent was we drop that patch if we don't need it.
Okay.
And so it sounds like we can drop it.
And it can't work anyway because of MSIX.
I had somehow convinced myself that if you have MSIX and it's not private, then you must report it as, the only way this could work is if you must report all of the things that are not private as non-T memory. That's the only way it could work. But if it says you can't report it at all, then yeah, then it can't work and you need this bar line thing. So let's just go with the bar line thing because that's what shipped in. The CCA spec put in there explicitly, and if everybody can do that, then it's easiest. Okay, so yeah.
Front page says there is PCI R8 spec available. I'm logging in and I cannot find it anywhere. I only see PCI Express 7. Do you have this draft? or it's not on PCI SIG?
Do I have the draft? I do not have the draft. I thought it would be like an errata too. Do they publish erratas too? Let me see.
Okay, never mind. I'll find
Okay. If I okay. Okay, so the trust level is new. We're gonna disable. So the other aspect of the trust level was so now the TCP is out, then we need a separate way to say, and this is back to Deshwant's issue of like, hey, how do I mark a device as inside the T from the start? And I think this is also going to apply to the stage 1 IOMMU as well, because that will also be within inside the T at the beginning of time. And at least in that case, I think that we'll just have a flag on the device that you can request that it's inside the T, and then when the driver binds, that decision becomes final. You can't change it at runtime, but you can.
That's not getting exposed as trust level, is it?
That's not getting exposed as trust level. I think that's going to need to be separate.
Okay, so we have this requirement of like some special platform devices, and also the device appearing on a special bus like VM bus, right? Which we discussed last time. So what we are essentially saying is that the bus when buying, like when probing or like when finding the device would set, it's going to be independent of the trust level.
It'll be independent of the trust level, and it'll be basically before you do device add, you will set this flag and then do device add. And then kind of after device add, you can't touch it, or at least like because we have this mixture of wanting to allow all the stuff to be set by public code, set by modules to change the stuff, but we also wanted to make it difficult for proper drivers not to change the stuff at runtime. And so I think it's going to end up being something that's like it's instruct device as a request, and then it becomes the actual policy in some private location when the driver attaches.
Okay, and okay, because then these platform devices doesn't need to go through the TSM framework at all, right? Is that like the T bit, all those things are independent?
That's the idea, that that if you're a verifier or you're trying to say, hey, you should be able to look and see, hey, these devices are claiming to be inside the TCP, and I don't have a TSM driver loaded. That's your policy decision about, do I trust the bus provider to operate that device? And so we're trying to push the requirements onto user space. So that if you see there's a TSM driver, then you know that you're going through that kind of TSM protocol to get this device into the T. If you don't see a TSM driver, then you know that this device was your bus provider or some other code made that claim, and it's up to you to figure out if that claim is valid.
But is the bus activity somehow equivalent to as a log state? Like does the user space still have to accept? Like there is a
I don't think so. Go ahead.
What I was actually trying to find out was there is a TSM in the guest which is going to manage the endpoint and all those things, and there are these platform devices which is appearing in some special bus which is inherently trusted. What would be the workflow? So there exists a TSM, and for this VM bus or platform bus, wherever that inherently trusted devices, the bus would say, these devices doesn't need to be managed by a TSM. And after that, what would be the workflow? Will that device automatically be able to access the private memory before the guest user space get to validate anything?
I think it should. I mean, that's my position. That if you have concerns about those devices that you were operating, that the assumption is that those devices had better show up in the comprehensive trust
Okay.
attestation report. So like because you basically when you boot up and it claims you're in a realm, you have no idea if you're actually in a realm or not until you actually do the attestation. And so it's kind of the same thing. Like this device claims to be part of the realm, you don't really know it, and you can find out later that oh yeah, whoops, it wasn't.
But the problem is device being able to access private. I think it is okay because I'm not supposed to put anything in the private memory until I attest everything. So maybe it's okay, like device being able to access private memory before I go and make sure this device indeed is good, right? I think it's okay.
Yeah, basically, is there a class of devices that should? I mean, you can also. I mean, but you have the policy to say like, okay, this set of devices is trusted and the driver binds automatically. These are built-in drivers, like they have to be there. Nothing works if they're not there. If they're there, and then you have another class of devices that aren't TSM managed, but you don't. But you want to be able to go through a verification step before you activate them. And then those, like you'd have a module or a driver that doesn't attach until you're ready. But for these platform devices, do they need to have like their MMIO validated and all these kinds of things, or are they integrated by default?
I think they are integrated, so I think they would be part of this platform attestation, right? I can double check. We are looking at there is a platform device thing. I need to check the spec again. I can come back on that. My understanding is they are integrated. Like there is no special action done, but I need to go back and check what is VSMMU kind of. We do have some VSMMU call. We haven't started implementing them. I'll check and come back.
Like on that one, and I think that would be similar to the Hyper-V case. It is this going to be a hey, if you're in a realm, you can double check that the address that you got for your RMU is the one that the realm is going to report the address, and then your ACPI table is going to report the address, and if they match, then you say, yep, it's a trusted device. That's all you get. And that would be the flag that says, okay, yeah, this IOMMU is inside the TCB because it matches ACPI and the realm and the RMM agree. That makes sense.
Yeah.
For the Hyper-V case, I think
we do have a activate call which the guest needs to make to actually activate this architecture device. Arc device is what we call. How do that plug in? If the bus is saying I trust this, that's not enough. Somebody needs to call RSA arc dev activate. So some validation is still needed, even if these are like, even if the device is like, I mean, so for example, in case of VSMMU or like stage 1, the base address will get validated, or like the guest needs to check some info from the device by using get info on the details, and then I say, okay, now activate this. But so we need to have that ability to do that. Passing this completely to bus, there is no TSM, right? So I'm not sure how we would.
There's no TSM, but there's also no other information. Like the bus has I mean, I guess you could make a decision about do I want to operate this thing or not. That's separate. So there's a driver decision, and then there's does this device meet all the claims that it could possibly make? And if the only claim you need to trust this device is RMM says yes, then as far as the bus code is concerned, you activate, right? Like you say, okay, I see an RMMU. I see that RMM says that my address matches what I got from ACPI. That looks right.
Okay, so
Activate.
you, okay, so you, um, what would be the bus? I mean, this would be the IOMMU driver then, is it? Is that what, like for example, if it is a VIOMMU, then it would be in the IOMMU driver?
Well, so I don't think I want the driver making this. The driver is the driver just. I think we want the drivers to just like be like the PCI drivers, where you just
Okay,
it's the same. The driver doesn't know or care. It just operates, um, and it can maybe find out if it notices that its DMA is being bounce buffered, but otherwise, like it's not the driver's not responsible for
okay,
converting. Um, so yeah, so let's say you have this thing, you activate it, but you actually don't want to operate it, then you wouldn't load the driver.
okay.
Um, because yeah, if it was fake from the beginning, then it didn't really matter if you activated it anyway or not. Um, and if you don't, but if you don't want to use it and don't want to trust it, then don't load a driver for it.
Yeah.
I think that's different than the selective trust case where you get all this evidence, you get interface reports, you get a whole bunch of things to know that you are talking to the right thing.
There is a similar activity here also. We have something called get info for the specific arcdev. Right now, the architecture dev that we are looking at is the VSMMU. So there is something called specific to VSMMU called VSMMU get info. And then we say RSI arcdev activate. Yeah, but I think I'll spend some time because I haven't looked at the VSMMU at all. So I don't have a mental model how this will fit in the TSM framework yet. So I can come back. But I understand from your point, like, you want this to be done by the bus, and then the driver decide whether to use this or not.
Yeah, at least for these trusts or these inside the TCP at the beginning of time things, you can still make a driver decision about I don't want to
Okay.
attach a driver to that thing.
Okay. And that decision will be made through some. So we had this trust none, which the driver core will prevent the binding automatically. Here it would be different, right? Here you will have to have some rules which says don't load this driver.
Oh, you mean if that's true because well at least it depends on if it's a module or not because yeah right now the only way to have a chance to say no is to um well yeah I mean you can say that all built-in drivers don't attach to drivers by default and you have to go manually bind them. I don't think that works because I don't think you might not even get to your initial RAM disk at that point. So I think the only way is it has to be a modular driver so that you have a chance to say, okay, in the initial RAM disk,
Okay, got that.
is when I can say no. Which works, I think, for ARM, but it doesn't work for Intel and x86. Well, it doesn't work for x86 because I think x86 IMU drivers are always built in.
Mm-hmm.
So we're gonna have it. So if we don't trust our stage one in those cases, that's going to be a different challenge. But again, like I think when if you're trusting, like part of the reason we have all this complicated flow is because the TSM itself doesn't trust the device until you say it should be trusted. But if it's part of the platform, the only way it could be this kind of arcdev activate flow is if the TSM itself are already trusted, and you can choose not to activate it, but you don't have to do this whole like established trust that the TSM also trusted. There's no SPDM, there's no certificates, and it's just activate or not.
That's what I was kind of getting to, right? Will there be that both the workflow, whether it is TSM manager or non-TSM manager, has this state of run, right? Where we say like, or DMA enabled equivalent one. So where the device is indeed now being able to operate inside the realm. But we are saying platform device doesn't have one like that. Right?
It doesn't have one like that because if you ended up not trusting it to be enabled within the thing, then you don't trust RMM, and then you don't trust anything.
Oh yeah.
Because if it was fake from the beginning, then your activity doesn't matter. you're already in the matrix. Right?
Okay.
I have a stupid question. When you say trust, what does it mean exactly? Because I'm looking at the current code, and it seems like it's coming from the trust parameter of a module, or whatever I hacked for built-ins. And it doesn't really depend on device being accepted.
Device. So the reason for that,
trusted means like device can be trusted if it passes attestation.
That means that the trust level is kind of locked in or evaluated when we bind the driver. The easiest way to, because like part of, and this might be my PTSD or whatever from having, we went through this like a year ago, or even probably even longer. We had this like the whole device firewall idea, and people were trying to like inject device IDs into the command line or other ways, and like inject this policy into the kernel. And the big feedback was like, we already have a way to identify devices. We have module matching, and so if you don't trust devices, then put everything in a module and use that to define your trust level. And so this mechanism to specify it in the module is just a coarse-grained way to say, hey, like I trust NVMe, and so I think basically the driver is hardened, and if I see an NVMe device, I can operate it in a trusted fashion. But that immediately breaks down, and I call that out when you have two NVMe devices, and you say I trust this one, but I don't trust that one. And so we're still going to need a per device knob to say I trust this device. Like so you can still have a module, you can still have NVMe not load until you've gone through and said, okay, I trust NVMe 1, 2, and 3. I don't trust NVMe 4, 5, and 6. Now I can load the module and set it that way.
See, I'm asking because I mentioned in the mail list you dropped the patch, which is allow encrypted device to map. Like if ever, it's the one which changes force DMA unencrypted to look at device CC accepted.
Yes,
what it was in the past. Now it should check for device trusted or device accepted, or both.
So the reason I dropped the architecture patches was because I wanted to make sure we had this discussion first about everybody agreeing on the trust levels, because nothing, and we're already changing them, so there was no point to kind of like go send x86 patches or ARM patches when it wasn't 100% certain that these trust levels are going to survive, and they've already kind of been
but I think it would be
reworks,
good to summarize what does it mean for force DMA unencrypted now. I think.
Okay, yeah. So force DMA unencrypted is going to have a read-only helper that goes and looks at device private the struct device private side, and it'll look for this flag that say, it'll be just say, effectively it's going to be a T equals 1 flag inside, and so it'll be almost identical to CC accepted. It'll just be a different name.
Okay.
We already have a flag now.
We already have a flag. We already have a flag now called accepted.
So it will not consult the trust level.
It won't consult the trust level. Because if it's trust level none, then the driver won't be loaded, and nothing should be calling force DMA unencrypted because no driver is going to attach to it. And if it's trust level adversary, then that means you can operate it in private mode, but you have to be you can't let the private mode mappings stick around very long, and that kind of thing.
No, if it is an advisory, the device will still be able to access private memory, right?
Yeah, it'll still be able to access private memory, but the driver will be careful. The driver will say, "Oh, okay, I need to make sure that I don't map secrets next to other, like in the same page, like that kind of thing." So like the adversary flag is going to do more than just have anything to do with DMA. It's actually going to set driver policy too. Like you might say, "Oh yeah, we're going to turn off these accelerations in our driver because we can't really make them safe if there's an attacker in our firmware." But if there's an attacker in our firmware, we can operate the driver in a very safe way that says, yeah, you can talk to private memory, you can run at full speed, but you need to have more enforcement.
Okay, so it is a sanitized private memory, so it's kind of thing, whatever, like you add necessary padding, make sure things cannot go. So it will do that via an IOMMU. So all of that is the job of the driver. We kind of punt that entire responsibility to the driver. Yeah,
we have the existing adversary kind of workarounds in the IOMMU layer. It knows how to do device untrusted. It'll do all those same things. And then additionally, a driver can also look at that flag and say,
okay.
But you're right, Alexi. I could just make it. I could just call it device CC accepted and be done, and not invent a new name. Because effectively, it's going to be the same thing, and it's not going to be the trust level. And the only motivation to rename it is just because that name caused Greg didn't like it. Greg's like, "Oh no, this should be based on trust," and so now we're saying, well, we can't make it. We're not going to base it on trust. We're going to base it on this other flag. But trust. Here's your trust thing over here, Greg. And by the way, we're still going to have just a flag for this kind of DMA handle question.
So we do need to check two of them: trust and acceptance.
We don't need to. Well, we don't need to check. We don't need to check trust in force DMA unencrypted.
Why?
Because
if you accepted the device but you didn't enable DMA, then you should force on. Well, then DMA will not work if it's force unencrypted.
Well, this was the debate I just had with Jason. Like, I thought we wanted a mode where we could say, let's operate the device with TDIS run state, but we're going to operate it without enabled DMA. And that was part of why the API was more complicated. And the reason we can get down to this kind of simpler, only 3 levels and a separate flag, is that we throw away that mode. So like that if you accept the device, you must turn on DMA. That you can't. We're not going to. At least we're not going to try to support this use case of. I mean, I think we can support it later if we wanted to. We could say only accept MMIO, don't accept everything. But right now we have an accept everything flag, and so accept everything means DMA will always be enabled, so we don't have to support. We don't need to worry about.
So this enable DMA and disable DMA hooks in TSM ops will go in next
No, those
revision?
will, well, no, those will be there because um, uh, because that's the most convenient place to do
But
the IOM. So like, because in DMA configure, that's where we're testing the IOMU configuration. Like that's so because in DMA configure, we're going to know that we have the T bits set. We're going to know that the trust level needs to be there. So we can pick our IOMU domain. The IOMU needs to know the T bit is set so it can do its special configuration. So like DMA configure is really a nice place for all this stuff to be resolved. And so that's why
What would be the condition that will be based on TE bits or trust level greater than advisory? Like right now
it's
you
trust
are
level.
doing that condition on TCB.
right now I'm doing that condition on TCB. But the thing that TCB couldn't express was how do you express adversary T equals 1? The TCB level couldn't express it.
Mm-hmm.
It was either full or nothing. It was either 100% or nothing. So with
Wait.
yeah.
Say I have TDISC device and I do lock accept successfully. Then a load driver, and I don't say trust equals yes. So the driver is probed, and it doesn't call enable DMA hook in the TSM, right? And it tries to do DMA. So that's gonna fail unless I do some SDT configuration at the accept step, which will allow DMAing to like shared memory with T equals 1 DMA. Like it will be T equals 1 on the bus, but it will go to the shared memory, so it will still work, and the device will not be completely trusted. Compared to as if module had trust equals yes, and then enable DMA would enable it like full speed and all security. So I can do both, but I have to do something to SDTE, to my IOMMU descriptor, at accept step. In case if trust level of the module is not yes, it's like false. Does this make sense?
It makes sense, but you can't separate. I mean, so it's okay to have that mode. Like, the first question I have is can you separate the SDTE write from the accept callback? Can you put that in the enable? Are those two separate steps?
I did put it in enable DMA right now in my tree, which I pushed out. I wonder if my module doesn't have trust enabled. Then nothing will write into DTE, and then all DMA from that device will not work. Because SDT needs to be active.
I think that if condition for TSM enabled DMA will be based on TE bits, not on trust level.
Right. Yeah. I mean, yeah. So like the new proposal is that because you accepted, the T bit is the devices in the T bit is set, and then at the very next DMA configure, we will always we will say, oh, there's a T bit set and there's a TSM present. We must enable DMA. So trust will not affect calling enable DMA. Will always in the new proposal will always call enable DMA.
Okay.
Yeah, in the current code, we do have this problem where you say, oh, hey, I did not trust you to be inside the TCB, but you said T equals 1, and now you got to operate in this weird mode. And that's a mode where we kind of went back and forth because Jason had kind of said, oh, like, hey, yeah, we might want this for like a something like doing software encryption. Like they could, but then he's like, no, it doesn't make sense. And so for simplicity, we're saying, yeah, get rid of that mode. Once you're committed to T equals 1, you're going to get enable DMA regardless at some point.
And that T equal 1 is the bus will set that irrespective of the device is attested or not.
No, I think a bus provider has the option to set it ahead of time, but the normal PCI bus driver devices are going to come up outside the T.
Okay.
And so when you set the accept flag, we will also set the T flag, and then that will all get combined together to this big evaluation at DMA configure time that says, okay, we see the T bit, we see the IOU, we see all the trust level, we can do this, we can do the weird adversary trust thing or adversary T thing or the full trust thing. So yeah, it might be the case that you set the flag that says we're inside the T before you do enable DMA, and that's okay because enable DMA won't happen until the driver binds, and until driver binds, nobody's calling forced DMA unencrypted, or shouldn't be. Yeah, yeah, nobody should be.
All right, cool. And this kind of answers my next question. Doesn't make sense to post my patches now. Probably not so much.
Not with the violence that's happening, but I'm going to spin it around. I saw Donald Hunter reviewed the Netlink stuff, which is good. I need to address his comments, but yeah, I'll try to get another version spun quickly and pushed out at least to GitHub. Jakob said he wanted to look at the Netlink thing. He's on vacation, but yeah, I'll spin it to get these comments addressed. We're not going to do the same latency we did last time.
And if we can kind of summarize forced DMA encrypted, how it should look for the backend drivers, like for CCA and for AMD, like in the cover, then we can also kind of start looking at doing the backend driver with the similar expectations, and we get that.
Okay. The other question that Alexei asked that I wanted to ask was, so the new proposal with the interface report is you get all the private ranges, and then we inject them into a resource tree. And because the problem with the old proposal was it didn't handle a bar being partially mapped encrypted very well, especially with the way we're doing request region, because then the driver would come up and be like, hey, I want to request my region, like, oh, but there's weird encrypted things in the middle of it. And so to move that aside, the current x86 IRBM implementation, when it goes to decide if something is encrypted or not, it does it based on the whole range. And with a TDIS device that might have a sparse map of private or not, there might be different settings all the way across that mapping.
This is IO.
And so
this is IO remap.
This is IO remap. Yeah, PCI like PCI IO map is just gonna pass the entire bar. But if the bar has mixed security, then what do you do? And so at least on x86 we can get the mapping, maybe make it make it all shared to start, and then walk this other thing and say, okay, make these parts of the mapping now private. We can convert them like that. Would that also work for ARM?
Yeah, for what we did for IO remap is to specifically look at each RMI granule and then look at their repass state and then make sure that is Dave, then only mark that as private.
Okay, so you have a granule iterator that you can say, for this range, give me the walk through each granule.
Correct.
Okay. Does AMD? I don't think x86 has that. Does AMD have that?
I'm not sure I understand. It's like some generic PCI code on ARM, which does that.
Well, the ARM has a thing where you can say, here's a physical address range. Tell me which of these pages or granules inside this thing are private or not.
How does this help with like PCI map bar API?
Because
Take the whole bar and the map.
because if the bar had a little was half, if the bar was half secure, half not, the x86 IO remap code doesn't only checks the entire range. It doesn't check each kind of section of the range. And so if you want to get one IO remap with one IO virtual address, you need to kind of change the page protections on a smaller. ARM sounds like ARM can do that. So ARM doesn't need this look-aside thing that I was adding. But yeah.
How does ARM know which part is private and which is shared?
It's a RMM call or RS. Or
yeah, there is an RSI call. I can just dump the details on the chat. Like there is an RSI call which we make during IO remap. Let me just.
So it's not based on report?
No.
Oh.
Right. Well, I mean,
I rely on the code from then, which looks at the report and adds the sub-region leaves in the tree of resources, which says encrypted.
We didn't plug it into the resource at all. It was kind of completely independent of the resource. So you can pass a range, base and size, and then say whether this range is protected or not. So when I do an IO remap, I look at the range and then set the table correctly with the correct copies and things like that.
Oh no, but that's that will still break, right? Because, well, size. I guess if it, let's say it'll come back as it's only true false, right? It doesn't give you like this extent based thing. So if you had an IO remap that was mixed protection, you would have to. I assume RSA directly would return false because it's a mixed range, and then you'd have to go. You wouldn't know where the boundary was, and so that's basically what
shared.
But don't we want to? So like the reason for this look-aside tree that we have on x86 and what that the code was setting up was so that you could walk that and say, okay, this first part is protected, this next part is not, this next part is protected, the next part is not.
Okay.
And
so what you are saying is there is a request to map the big range, and some part of that large range is protected, some part of the large range is shared. How do we map that? It's one operation, right?
Without needing to go update drivers to say, oh, by the way, you can't use your good old fashioned map the bar thing anymore. Now you got to do this careful piecemeal thing. Like,
yeah, but what is the PCA function which does this large one? I can take a look. I never came across
PCI IO map.
Okay, I'll take a look. Yeah.
And I think most PCI drivers just use that, and they don't understand that their bar could be fractured into tiny pieces. Yeah. So yeah, I'll redo the x86 patch. On top of that, I just kind of ran out of time. I wanted to get something out, but that should unblock that.
By x86 patch, you mean the one with the resources, right?
The one that walks the resources and
right.
But yeah, it's going to have to be different because it's going to have to be. do the mapping, get the vmalloc mapping, and then go do set memory encrypted in small pieces.
Right. Good. I'll review and test.
Okay.
I already tested all of it.
Oh, yeah, with the disabled. Oh, yeah. I guess my last question. Like, so I think we want to come up in a mode where if the driver, well, in the beginning of time, we don't know if the DMA is active or not, but we definitely want to like have DMA be enabled at DMA configure time, and then if you enabled that, you disable it at when the driver is unloaded. And sounds like you tested that. It sounds like you tested DMA disable in the DMA cleanup path, and that worked for you, Alexei?
I had to add it in the tree.
Yeah, we had to add it. Yeah, I didn't have it, but yes, you added it, and it worked.
No, with that one, I can lock and lock in the loop, and still works.
Okay.
And netlink works. And for that, I had to fix Anish's tool, work with new netlink, and new whatever it is. I don't even know the difference because I asked Claude.
So in my Git tree that so I didn't post the patches, but in the Git tree there's a utility that there's also a utility there that uses the automation to generate the blob parsing. But yeah, if you have it hand coded, that's also fine. But the how I tested it, the C tool I used to test the netlink thing is in that tree as well.
I had this question around netlink. There was this discussion about do we need to have a flag added to the netlink? Like right now we do a nonce, right, to generate these details. So right now when a TDI asks for like measurements, we are essentially sending the measurements of the full device, not a specific TDI, right? Because at the SPDM level, we are sending it to a mailbox, which is function 0 kind of a thing, and we are getting the full device measurements. What if we have the possibility of having like a per TDI measurements later? Like, can netlink add a flags later, like which we can give more details of what type of measurements we are requesting for?
I think that's kind of why I like netlink is it's easy to add things. So yeah, we could add another attribute and say, yeah, if the attribute is rejected, then you can't do it, and if the attribute is accepted, then you can.
Okay.
Or a flag, and so yeah, because I had that question too, like, oh hey, what happens when, because it's also kind of coming up with the native SPDM support, because they want to be able to. There might be a DOE mailbox per PCI function, and so you want to have
exactly.
You might have per function evidence. But also, yeah, again, like in the case, would it ever be the case that you have both, where you say like, hey, I have a function that also I can have my local evidence, but I can also get global evidence, that you would need to pick both, or it would just be a new model where. Because basically, we might not need a flag if the function can only.
So the way I'm actually looking from a spec point of view is like, right now we'd have this notion of VDEV in RMM. So VDEV evidence is like a per function evidence, and like the moment we support a per function evidence, then it's essentially what the guest needs, right? So the guest request is essentially for a per function evidence, right? It's not really interested in a global evidence at all from a guest point of view, right? Or is there a need for, so that was the question I had. Will the guest ever ask for a global evidence? Because the guest doesn't know about the global thing. Guest only knows about that function which was passed, which we did the pass through, right?
Yeah. I think it would probably be a case of the guest never wanted the global stuff on the anyway, but it's just getting it, and now we're truncating it to something smaller, and it probably wouldn't care.
Unless in the evidence attestation path there is some extra details which the guest needs to know, in which case the guest needs to have the ability to ask for global evidence. So which means then what you ask for is needed, right? Where it says that, oh, I need global evidence now. The local evidence is not complete or something like that.
Yeah. Yeah, no, I think it's straightforward to add a flag if we need one.
Okay.
The other question that came up, I think, was, and we're looking at it, is I think this might be only an ARM and Intel thing because AMD has the SPSM to do TPM, but like, should we be logging acceptance events, like logging the evidence or hash of the evidence into some kind of audit log that can be evaluated later to say, okay, yeah, this is the point at which you accepted this device, and then when you go to the verifier can replay the log and be like, oh no, you shouldn't have accepted that thing at that point. And so I guess this comes back to like, yeah, we can get all this evidence out of the user space, but then the very next question is, okay, now what do you do? Now what? Do you put it into some kind of global log and accept the kind of final validate the final kind of PCR or equivalent to a PCR value? Do you ship off evidence one by one? Those are kind of questions I'm fielding right now, but I don't have a good sense. But I know some people want to do this mode of measurements. The devices are measured into a PCR kind of mode, and then the verifier gets the launch attestation report and it gets that log, and then it says if you're good or not.
Has anyone actually spoken with the attestation people on what they're expecting here? Like anyone in the attestation working group or say the Azure attestation services, things like that? Because right now we seem to be coming up with what we think people want when there's entire groups of people at Microsoft and other groups that do this already and probably have expectations. That would be good to know.
Yeah. Some of these heard it through the grapevine requests. I need to do a better job of pulling, like, did this come from like those attestation working group people? Are they asking for this, or are these people are inventing things? I think it's more of the former, that this event log thing is what the attestation people want. But that's a good point. I shouldn't be guessing. But at a minimum, we know we definitely need to get certificates and interface reports and everything out to user space. So everything after that is add-on. Yeah, but if anybody hasn't, if people haven't heard about that, then we're okay for now.
So in this entire workflow, is there an ability to change the slot number of the certificate chain that we are using to set up the entire flow? Are we looking at providing that anywhere? At least in the, I think we picked that on the host side during Connect, isn't it?
Yeah, you can't. I mean, well, you can invent a new guest to host interface to ask that it be changed and ask to reconnect. So maybe when we get to guest directed connect requests, we would also figure out a way to pick the slot. But that would also be just a new netlink command to say, change the slot to not 0.
Okay.
At least that was the intent.
Okay.
But as it is today, yeah, you pick slot 0, you get all the way to the guest, and guest says, I don't like slot 0, and then you got to like. But that should be a misconfiguration with your providers. Like your provider should have known that ahead
Okay,
of time.
got it. Yeah.
But like, yeah, and I don't think we're really targeting, like, even though the spec allows for it, I don't think anybody's really targeting the kind of multi VDEV to multiple tenants kind of use case yet. So 'cause that would also be a problem if tenant
Yeah,
one wants slot 0 and tenant 2 wants slot 2.
yeah.
Yeah. Yeah, so that was kind of that was kind of the office hours on the core bits. Look for a V2. 'Cause I know this was a lot of discussion that people might be like, "Oh, what are you talking about?" So try to get that out pretty soon here, and we can go from there. But otherwise, thanks for the good discussion.
Thank you.
And we'll see you all at the next one.
Yeah, thank you.
Thank you. Bye.